Start day 11. Let's go back to the free response from day 3. Remember, it was a simulation right here. Again, please make sure you go in and open up the scoring rubric. Scroll down to question number 3. It's a pretty short rubric. It's on pages 7 and 8. Take a look and see how you do, and let me know if you have any specific questions. Day 11, let's go into chapter 6 and review random variables. Some of the things about random variables is, remember, we had to calculate the standard deviation of a discrete random variable, and then also interpret the standard deviation. We then talked about transforming, what happens if you add, subtract, multiply, and divide to a constant. We then were challenged to compute the new mean and standard deviation of the sum or the differences of an independent random variable. And then we used and calculated some probabilities from that. They also brought in our binomial random variables at that time. And we did binomial CDF and PDF. And also we learned how to calculate the mean and standard deviation of a binomial, in addition to looking at the geometric. So chapter 6 is probably one of the trickier ones for probability for students. So let's take a look at some of the key concepts. Now in section 6.1, that's when they really talked about the difference between our discrete and our continuous random variables. Remember, discrete random variables are the things where you have whole number answers or things that are finite. So if someone said, how many children do you have? You either have 1 child, 2 child, 3 child, that's discrete. And that would be either binomial or geometric, possibly. Continuous would be if someone said, what is your weight? Your weight could be anything that has a decimal, and that decimal could go on forever. So that would be more continuous, and possibly that could be a normal distribution. We're not sure. You were asked to find the mean of the random variable. The formula we did here, remember, just take the table of distribution they give you, the outcome time probability, and add it up. They then introduced the standard deviation of the random variable. Remember, this right here is the variance, so sigma squared is variance. What you would have to do for this one, compute the variance. Remember, this just says take the outcome minus the mean and square it times the probability of that one event, and do that for all the events and add it up, and then take the square root. This formula is found on the formula sheet. Section 6.2 then jumped into more of linear transformations. Remember, this really sums it up right here. If you do a linear transformation, what's going to happen to the elements and how do they change? It says here, the shape, center, and spread of the probability distributions are as follows. The shape is going to stay the same no matter if you multiply or divide a distribution by a certain value. The center, what this is going to tell you is if you add or subtract, the center is going to change by that value. If you multiply or divide, the center is going to change by that value. Whereas the spread is not impacted by adding or subtracting, but it is impacted by multiplication or dividing, and it would be by the absolute value of it. So this is if you're going to take, a current variable. Let's say, for example, you have a distribution of test scores. I wanted to double those test scores. So if I doubled those, the transformation would be times by 2, so center and spread would change. Now, what's the difference between two random variables? Well, what if I had one test and a second test, and I wanted to combine two different test scores? That would be the combination of two random variables, not a multiplication of a transformation, but combining. What if you want to find the difference of two different test scores? That would be this right here. Remember, the mean of that, if you add, you literally add them. The difference, you subtract. Now, the standard deviations, you're going to have to compute their variances first. So compute their variances by adding their variances together, the two variables, then come in and take the square root. Now, the sum or the difference of two variables, the variance and standard deviation are treated the exact same way, because when you bring two variables together, you're going to have more variability. Think of it this way: if you have one person in a relationship versus two, when you bring in a second person, there could be more conflict and more variability in your decisions. That's why you always add your variances together, but you subtract the means if it is a difference versus if it's a summation of it. In the shape here, if you take the sum or difference of two variables that are both normal, you're still going to have a normal distribution for the shape. You're asked to describe what it looks like when two variables come together. You have to talk about the shape, the center, and the spread. Don't forget your socks. 3 is going to talk about binomial again. Remember what binomial is you want to remember your bins. So you're going to have to say before something is binomial, is it binary, where it's either success or failure? Is it an independent situation? Is there a fixed number of successes? And is the probability of success always the same? If these 4 conditions are met, then you can use binomial. This formula is here on the formula sheet. This is going to give you the number of combinations that you can get for binomial. This here is your probability of binomial. This here is the center and spread, or mean and standard deviation, of a binomial distribution, where n is your number of trials, p is your fixed probability of success. You can compute your probabilities on this. Like I mentioned before, you first have to check, does it meet the binomial situation of bins? If it does, then you can go ahead and you can do binomial PDF or binomial CDF. Remember, in that case, PDF is for a point, so if they're trying to find the probability that x equals 2, whereas CDF is for a range, so maybe it's the probability of x is greater than 2 is what you would use for that. There is another time where if you want to do a normal approximation, we didn't really touch on it that much, but if you can approve approximately normal, you could use the new mean and standard deviation. The mean for a binomial distribution is going to be n times p, and the standard deviation is right here. Those are both found on your formula sheet. Now remember a geometric setting. In this case, you're going to check if bits works for that one. So very similar to bins, we're looking for binomial if it's success or failure. The independence, the number of trials until the first success is what's difference between geometric and the binomial, and then a constant probability of success. So this is geometric is when we have the very first success happening, is when we want that one to be the case. If you do want to find the probability for geometric, you could by hand. This here is on the formula sheet, and you could reference it if you wanted to. You will not find the mean for the geometric distribution on the formula sheet. It's just 1 over p. Now I will tell you, again, Chapter 6 tends to be one of the trickier sections for students that they want more practice on. So let's jump into the multiple choice and free response for this. Fabulous advice to stay focused on this one in particular. Try the multiple choice, really read the feedback in terms of if you get the wrong answer. And this free response actually deals both with chapters 5 and 6. So let's take a look at that. This was a 2000 B exam, so it was the second test that they gave for that, and it was problem number 2. I'm going to have you really try this and think about chapters 5 and 6, how you could approach this problem, and then just go into the assignment, pull up the grading rubric for this one, and look for question 2. And we'll resume and talk strategy about that one tomorrow. So good luck on your day 11 review.